Doc with the review for the first Physics of Sound and Music lab exam, and we're going to look at a review of Lab 1 in this first video. The first lab exam consists of 5 labs to look over. Labs 1, 2, 3, 4, and 5. This is the sheet that reviews for you what you need to know for this exam. I just simply clicked on it to pull it up as a PDF file here, and you can do the same thing just to follow along or have your printed copy there with you. It'll be easier for you to follow this review. So let's look at the first thing here. I'm going to give you the lab screen here so we can go over some of the questions. Examples. The first one says relate meters, centimeters, and millimeters. If you can remember that centa, the metric prefix, means 1/100th, and milli is 1,000th, and that there's 10 millis in a centa, you're all set. You can do the meters, you can do the seconds, you can do the hertz, you can do anything. So just remember those 3 rules, and we're going to apply them now with some numbers. If we're looking at, say, millimeters and centimeters, and you want the millimeters, remember that there's 10 millis needed to make up a centa, which means a centa is bigger. So each centa is 10 of these little ones, so that means we have to multiply by 10. So this is 4100, 4,100. If we want meters, then if you have hundredths, and here's where money helps me. Hundredths, if you think dollars and pennies, 100th of a dollar is a penny. So I see this as 410 cents. If that's 410 cents, I need $4.10. And you could have a 0 at the end of that 1 with that point there. It's not going to change anything. So here's another one here. 270 pennies. I can get this quickly. $2.70. That has to be the answer. And look at that. Here you can multiply by 10 to get your millis. Another way to do it is you think of the decimal point. Here, to go from meters to centimeters, you move the decimal point to the right twice, 1, 2, and get 270. And to go from cent to milli, you move it over another 1 to the right and get this one. And to go backwards, you just reverse the logic. Decimal point moving helps some. If it helps you, use that trick. Here we have the same thing with the seconds. Same thing applies. Exactly the same. Just don't let the seconds throw you. Instead of having centimeters, we have centiseconds. Everything applies from before. When you go to the next thing on the sheet, it says, how do we relate distance, speed, and time? Well, we're familiar with this kind of a problem from like riding in cars. If you go 480 miles in 8 hours, what's your speed? And you would figure out it's 480 divided by 8, and it's like 60 miles an hour. Now 60 miles per hour, whenever you see a per, it means divide. So that kind of suggests what to do here. I'm going to recommend you memorize a formula. D equals VT. D is distance, V is velocity, and T is time. You multiply the velocity times the time to get the distance. So 60 is your velocity times 8 is 480. You should rephrase this problem 3 ways to make sure you could figure out the 480 if you were given the 8 hours and the 60 miles per hour. Make sure you can figure out the 8 if you're given the other 2, and make sure you can figure out the 60 if you're given the first 2. You have an equation with 3 things. So there's 3 variations to the question. I give you 2. You give me back the third one. So make sure you can work that out and you'll be all set. So next it says, what is the metric prefix for 1,000? And that is kilo, the kilo. So here, how many kilovolts are there in 80 million volts? Now, you don't have to know what volts mean, refers to. That's not the problem. Don't even worry about that. This is 80 million. A million would be here, if you wrote this down, 80, 000, 000. And a kilo is 1,000. The key here is to forget the 80 for a second. How does million relate to thousands? Well, a million has one with the 6 zeros, and 1,000 has one with the 3 zeros. So a million is 1,000,000. In other words, if you had $1,000,000 and you had in $1,000 bills, you would have $1,000 bills. So $1,000 bills does it. So when I see this 1,000,000, I know I need $1,000 bills to get 1,000,000. But I need 80 million, so I'll take that 1,000 there and put an 80 in front here, and that is my answer. This is going to be 80,000 kilovolts. I had placed a period there before I noticed I meant a comma, so it's 80 comma 000. If we go next, it says estimate distances in kilometers. It's nice to know your relationship here. You should know that a yard is roughly the size of a meter, and there's 3 feet in a yard. So if you want to go from feet to meters, it's like saying how many yards are there. It's like the same thing. So just divide by 3, you get 500. And if you have 600 meters and you want it in feet, just pretend that's a yard, and then you would multiply by 3 and get 1,800. For the miles and the kilometers, what you do there is you remember that there's this 2/3 rule, 3/2 rule. All right. More precisely, it's 5/8, 8/5, but 2/3 is close enough to get a quick estimate. And what's going to happen on the exam is that you're going to forget whether you use 2/3 or 3/2. This is a common mistake, or think backwards. Well, here's how you make sure you don't make that mistake. You remember that a kilometer is a short mile. That means it's smaller than a mile. Think of it as like a baby mile. It's a short mile, younger brother. So the kilometer you have to have more of them to get something like 20 miles. So the number in front of the kilometers has to be greater than 20. That right there tells you have to use 3/2, because if you use 2/3, you'll be going the wrong way. So 3/2, 2 into 20 is 10 times 3 is your 30. 27 kilometers, these are the short ones. So miles, they're bigger, so I don't need I don't need that many. So therefore, do I use 3/2 or 2/3? I use 2/3. 3 into 27 is 9, and 9 times 2 is 18. Next is the Vernier Caliper, and that is a device you practice with here. And I recommend just looking over again, a little bit of review. The way this one works is your answer is going to be, in fact, we can show it here. The answer is going to be the number that the 0 is in between here. You go with the left number. So if you're between 7 and 8, you go with 7. So see, this is 5, 6, 7. You go with the 0. Make sure you don't go with that leading edge. Go with the 0. So that's 7, and then the decimal point is going to be your 0.6, because that's where you have the things lining up. So that's the way to do that one. And next one says quarter notes, measures, and all that. That would be up in here. See, the review sheet's kind of directing you to a few of these, so you don't have to go over the entire lab. Here the question is, let's do these over again here. The question is, how many measures do you need to accommodate 40 quarter notes? Well, information is given in the problem, because you don't have to have music to take this class. So it says here that we're looking at time proceeds from left to right. Okay, so we read this like a book. That's okay. And it says you have 3 measures, all right? 1, 2, and 3. You can see where the boundaries are here. So 1, 2, 3. And it says also more information I don't really need. 2 piano score. Okay, 1, 2. So one piano is playing one thing, the other plays the other. Don't really care about that information. And it says here that I have 3 measures. I need to know about quarter notes. So given the fact, here it is, that each measure has 4 quarter notes. Okay, 4 quarter notes in each measure. So 4, 4, 4. So it's 4, 8, 12. All right, 12. So 4 quarter notes in each box. Well, I have 40 quarter notes. 4 in each box, going to need 10 boxes. So that's how we figured that out. Then there's another one that talks about time frame. So here you have the 3 measures again, and 4 in each box, 4 in each measure. And it says here we're going to do 120 quarter notes in 1 minute. Well, you might want to figure out how many per second, since that might be relevant. You don't have to, but let's go ahead and do that here. If you have 120 per minute, you're doing two a second, right? Because there's 60 seconds, or 60 seconds in a minute. So 2 times 60 is 120. So we're doing 2 a second. Wants to know how long it takes to play 48 measures. So if I'm doing 2 a second, but there's 4 in here, remember 4 in each box, that means 1 second, 2 seconds. That means 2 seconds for each measure. So it would be 2 seconds, 4 seconds, 6 seconds. All right, well, how many measures? I have 48 measures, whereas 2 for each second, so I just multiply by 2. And on the exam, probably numbers would be a little bit easier than 48. But if you double 48, you get 96. 96. All right, it's like your exam. 48 out of 50 are correct. You know, each one's worth, 2, like on the 100, so minus 4, so it's 96 is great on that. So let's go. What's next? We have the definition of wavelength, frequency, and amplitude. And here your wavelength is your distance from one peak to the next if you go left, right. More precisely, it's one pattern. So here I could also go from, let's say, from here to here. That distance is the same as this distance. Or I could do one pattern. Wiggle down, wiggle up, wiggle down, wiggle up. So there's one pattern. One pattern here could be thought of as a valley and a mountain. Or you can start here with the mountain first and a valley. It's going to work in either case as long as you encompass one cycle. That's the wavelength. Your amplitude is measured from the equilibrium line, the middle line, so it's the number above here, the axis. It looks like it's around 0.9, between 0.8 and 1. That's your amplitude. And the next thing says frequency. That means how many times you're wiggling per second. So just remember that this is a wig. That's the goal. You got to include both. Wiggle. Say wiggle, wiggle. And how are, let's see, you going to get frequency in period, all right, and milliseconds. That would be, for frequency and period formulas, that would be your 1 over t. Your t is your 1 over f, and your f is your 1 over t. That's what you're looking at there. And if you in fact, write those formulas down. You can write down F equals 1 over capital T, and capital T equals 1 over F. And if you're given the F, you just go ahead and divide. So if the F is like 2 hertz, then 1 over 2, that's a half. That's your period. Half a second, 0.5 second. How do you handle second with our milliseconds? Well, with milliseconds, I recommend you remember another pair of formulas. Write down F equals 1,000 divided by t, parentheses in milliseconds, because you want to emphasize that the t has to be in milliseconds. Use that formula, otherwise you get the wrong answer. And then you can write down t in milliseconds equals 1,000 over f. So you have those 2 pairs of equations, and then if you have a question like, what is the frequency for 2 milliseconds, you say, well, I use my 1,000 over 2. It's 500 hertz. What is the milliseconds if the frequency is 100 hertz? Well, I want the t in milliseconds, so I would use the 100. I would use 1,000 over 100. So I would plug the 100 into that formula, and 1,000 over 100 is 10. So that would be 10 milliseconds. Well, it looks like that is everything on our sheet. So I guess we're finished the first review.